Hello everyone. Today we are going to discuss the problem of the latest Leetcode weekly contest 370. Problem named maximum score after applying operations on a tree. So there is an undirected tree with n nodes labeled from 0 to n minus 1 and rooted at node 0. And you are given a 2D integer array as is of length n minus 1 where as is I denoted AI comma by, which indicates there is a as between AI to by. And you are also given a zero indexed integer array values of length n, where the values I is the value associated to that node. And you start your score with zero. In one operation, you can pick any node and add the value to your score and set the value to zero. A tree is healthy if the sum of all the values on the path from the root to any leaf is not different than zero. We have to return the maximum score we can obtain. So, to understand the problem statement, let's tackle this. So let us suppose we are having a node. So, so a tree is healthy only if the for every like the from the root. This is the root. So from root to every leaf node, if the sum is not zero. So here there are two leaf nodes, 0 and 1, and 0 and 2. So if we talk about 0 and 1, if I talk about 0 and 1, so if the sum of these two are not 0, then we can say this is healthy. Means all the path from node to every leaf node is non-zero, then we can say this is a healthy tree. And if we pick, let us suppose if we pick this node, then we can add this value to our score, right? We can increase our score by this value of that node, which is already given in the values. But then its value becomes zero, and we have to maintain the tree as healthy as well. So in this in this tree only, if I just mark the zero node, I just pick that node and make its value equal to zero, right? Then one and two having values, right? So what can be my score in this case? So in this case, my score should be the value of node one plus the value of node two, right? This is the possible case in that. And uh, if I if I don't mark this zero node with zero don't mark this so in that case what can we do? Let us suppose if I pick these two, if I mark these two values as zero, because we do this, right? So now this having a certain value, right? And certain value, and we can we I know these values become zero. One and two's value becomes zero, and the only value left is zero. So our score in this case is zero, right? The value of the score. So we have to take the maximum value among all possible cases. So in this case, what is the answer? My score is maximum of the sum of one plus two or either zero. So let us take another tree which is given in this example. So if I take that tree, right? So if I take that tree only, then what can we do in this if I take that tree? So yeah. So if I let us suppose if I mark the means I just mark this value, pick that value into my score and mark it as zero. Optimally, what we can do, like if we pick all the values, right? Let us suppose if I put this also, I pick zero also, two also, three also, four also, five also. So all these values become ultimately zero, and the tree is not Now the tree is not healthy because uh, for for any path between 0 to 1, the sum is not sum is equal to 0. So we have to maintain the sum is greater than 0. So for that we can't mark every node. So we have to mark in such a way like we can maintain that property also, and we can maximize our score, right? So for that we have to like maintain some we have to observe something, right? So if for example, if I mark that node, right? If I may mark this node, so now we can know these are having any value, and these all nodes having certain value. So in this case, this is healthy because the sum is from root to leaf is greater than 0, right? And this will add up to me some plain value, which is my current my score, right? Which is my score. Now, if for example, if I again if I mark this also, so will this affect the healthiness of the tree? No, because these two are having the value which is greater than 0. So we can mark this also, and we can mark this also, right? And we can't mark this and this, because if we mark them, this the path between this root 0 to 3 is not remain empty, right? So we, and also in this case, in this path also, we can, what we can do, we just mark this and this, either we can mark this and this. So there are a lot of cases. We have to choose for the optimal one which maximize my score. Our ultimate goal is to maximize our score, right? So what can we do for that? So for, like in this example also, for a given node, for a given node, we check all the, we check the minimal, like we check the minimum values from the subtree of that given node. Like in this example, if I check like if for 0, so the minimum value from the from its subtree is like from this it can, it is 1, and from this subtree it is 2, and from this subtree it is 3. And there are three, means there is a case we mark all these, like we mark 0, 2 and 3, right? uh, like we can't mark these values because these are a minimum, so we can't mark these, we can't pick these values, so which maintain my tree as healthy. So in this case, what is the sum? 1 plus 2 plus 3, which is 6, right? This is 6, and the value of zeroth node is, let us suppose, uh, is 4. The value in the variable, the base is 4. So it is beneficial, like if I mark 4 and I don't mark these 1, 2 and 3, so it is beneficial to mark 4, to mark 0, so which only cost me 4, so which only cost me 4, and the properties also remain the same, like I don't mark this, so every node is, like I mark every other node other than this, means in this case we can say, in this case we can say like I mark every node other than zero. So this is also marked, this is also marked, this is also marked, this is also marked, and this is also marked. So ultimately my score is the sum of all these, right? And this will remain healthy because the node, the root having not marked. So uh, this will give me the optimal answer. So for every given, for every node in such, but there is a possibility like this is the node, and this, this. So right. So if I mark this, it will give me like, there is a possibility like this is the, this having the maximum score. This is the score. This will add up the score greater than this node. So it is beneficial to mark this node, and this only can make the left subtree healthy. But we have to also check for the right. So we have to return a minimum value in the left subtree also. and for the left minimum and right minimum, we add these two and check with the root node, because we have to take the minimum so we can maximize our score, right? So for that, what we do, we call a DFS from every node and check values, the values from the left subtree and the right subtree of every given node. And if the sum of the, like, if we are at a node and this left subtree return me some minimum value and the right subtree also return me some minimum value. So let us say this is L, this is R, and the value of the root node is well, right? So if the value of the root node is greater than the L plus R, in that case, what can we do? We just mark these, remain the mark these LNR, and we don't mark this, right? And if it is like L plus R is greater than value, so in that case, what can we do? We just return that value, because this is the optimal value we have to mark, right? So from every node we have to call DFS and do this. So let's uh, see the implementation of that for the better understanding. So what I do, I take I have to return non-norm, so I just take the size of the array, and then I create a graph and put the values in my graph and maintain a leaf node which check whether a given node is leaf or not, right? So how we know a node is leaf? We just store the in degrees of the node. And if a node having only in degree one, then we can definitely say it is leaf node, right? And then we summed up all the values of the values in the node, in the tree, because we know the values that we also know, so we can sum up all the values in the sum. And then why we do, I will tell you why we do this for a certain cases. And now I have to check for not pick those values we are not picking. We have to maintain a minimum not picking array which I subtract from my ultimate sum, right? So for that I call a DFS. In this the parameter, there are certain parameters, node, parent, graph, and all. And in else subs zero, what I am returning the minimum value of the left and the right, the minimum value of a subtree from a given node. So what I call a DFS, and I add up all the values from the left and the right subtree sub, and then ultimately what I check, if the sub means the minimum values of the left and right is greater than the value node, then we have to return minimum. So in that case, it is beneficial to not pick the node, the root node, right? So in that case, we return that, and else we return the sub, means the left and right remain unmarked, not picked. And in the leaf, that's why we are calculating the leaf nodes. So if a node is leaf, in that case, it don't have any, means it don't have any left and right subtree, right? It don't have any subtree. So in that case, we have to just return that value only. So that's why we are calculating the leaf node. And finally, why we are doing the zero to increase by one, because we know zero is our root node. So in, like, for example, if we having this as my graph, so in this case, both having in degree at one. So in these cases, we don't, like, we can't say anything about both. So in that case, we have to start from anything, right? We have to start from zero or the root node. So in that case, that's why I am increasing this. I'm increasing the in degree of root every time, because in that case we have to return something, right? So this is then the final answer is the ultimate sum minus not picked values, right? So I hope this problem is clear to you all. And for more such content, follow to our YouTube channel. Thank you.